speaker, ladies and gentlemen, Dr. Sriram Rajamani is a corporate vice president for CoreAI at Microsoft. He has led the foundational research and product integration efforts that bring AI directly into everyday's developer and business workflow. He's currently working on reimagining the future of programming and software engineering in the era of large AI models. Please put your hands together for Dr. Sriram Rajamani. Welcome, sir.
Thank you. So thank you for inviting me here. I'm very glad to be here. My background is in programming and programming languages. I've spent my entire career building programming tools for very large teams. And the advent of AI has dramatically changed and increased very dramatically what programming tools can actually do. So we are living in an exciting era where programming and software engineering are just being disrupted and changed before our very eyes. But in this talk, the organizers also wanted me to talk about spreadsheets, which are also programs. So I will actually relate my experience building tools for programming, to also programming spreadsheets. That's what my talk will be about. But before I go there, I want to give you a little bit of sense for the capabilities of these large language models that enables these disruptions, both in programming and in spreadsheets. So let me just step back a little bit and say the technology arc that is enabling all these things. So a story of about 2 or 3 slides. In 2020, the first real large language model called GPT-3 was unveiled. And then in a couple of years, we had GPT 3.5 and GPT 3.4. And those disruptions relied on 3 insights. The first one was a particular neural net architecture called transformer architecture that was incredibly effective for very many different problems. The second was an idea called self-supervised learning, where, before this, people used to have to construct data sets for every problem. Right? What self-supervision allowed you to do was to take any text from the internet, and this you would recognize from Prime Minister Nehru's speech, hide one word there, tryst, and then say, ask the machine to actually guess that tryst is the answer. Right? And you could do that for every word in every document, and this you could do without any human effort. All you needed to do was to just look at all the documents in the world and play hide and seek with it. Right? So the machine could now guess any fill in the blanks. Any blank you miss, the machine can guess. The third idea was that you just do this with very large scale. Just puts lots of data, put many, many parameters in this LLM, and these LLMs have something called emergence. If you train LLMs like that, even though we train them to just do fill in the blanks, when with 8 billion parameters, they started answering questions. At 62 billion parameters, they started summarizing. And about 540 billion parameters, which is where I come in, they started generating code, right? Even though we just trained them to just fill in the blanks. So this was a real revolution that happened around 2020. And these LLMs now became completers, in the sense that you could say something, and it will complete what you're saying. That's what these LLMs could do. As a result, right, the first generation of coding tools were all completers. If you look at the first generation of GitHub Copilot, right, it will just watch what the programmer is typing, and it will complete it for you. Right? So this was the first generation of programming tools. What happened since then, over the past 2 or 3 years, is that there is a new technological trend that is happening called post-training, which is after you train the LLM to do this next word completion, you train it to do question answering. You train the LLM to say, here is a bunch of questions for which I know what the correct answers are. I maybe have collected the data set for my domain or by employing people. Then what I have is actually, I have a question, and I get 2 different answers from the LLM. And then I have a human or some other model predict which one is preferred and which one is less preferred. The third one is that you have a goal, such as you want to play a game to win a game, or you want to take multiple steps, but you have an evaluator that decides which answer is correct. Right? Using these things, you can now turn your just next token predictor into something that does tasks for you, right? There is also a recent development called inference time reasoning, where this kind of asking the LLM to do a task, the LLM spends more computation during inference time, right? And these are benchmarks where using inference time reasoning, You get higher answers like in the 70s and so on, but before inference time reasoning, these benchmarks, we could solve them only like 30 points, right? So these advances has resulted in new kind of capability called agentic capability, right? Unlike the previous generation of LLMs where they could only complete sentences for you or fill in the blanks for you, with these LLMs, you can ask them to do a task and they can invoke tools and do the task for you. As a result, the new coding agents are very different. Instead of, you can just say, create this service, do all these things for me, and these agents can create multiple programs, multiple files. They can create tests for you. They can run them for you. They can check whether your program compiles. If it doesn't compile, it can look at the compiler error messages and go and fix the programs. Many, many steps that humans can do, these things can just do automatically. This is actually absolutely dramatic that is actually happening right now. And this has many consequences for many industries, in particular programming, right? So if you want to do any, these days, right, if you want to develop new code, you don't just write the program. You go talk to these agentic LLMs and say what you want to build. And these can build new code, they can build documentation, they can build tests, and they really dramatically increase the speed of exploration and prototyping. But the responsibility of understanding, validating, and maintaining this generated code still rests with the human. The human agency is very important because just because the LLM generated that code, it doesn't take responsibility for that code. If there's a bug in the code, you as a human being who is using this is still responsible. So that's actually the contract that you have when you're using an agent. What I work on in Microsoft is not just this. I work on how to make these LLMs manage very large code bases that we have inside Microsoft, right? Like Windows and Office and Teams and like PowerPoint. I mean, those are like 30 million lines of code, 50 million lines of code, right? What you can do is actually, in addition to creating new code, you can also use LLMs to help you manage existing code, very large code bases, by just talking to the agent in natural language. You could say, oh, I have this problem in my code base. Can you explain to me how this code even implements this feature? And then help you fix it, which is very important because in many teams, right, there's a lot of churn. And the people who wrote the original code may have actually even left the company. New people may have joined. So LLMs greatly help you with these scenarios as well. But the most important thing is actually even here, the LLM only proposes. Understanding and managing the edits that are done that are proposed by LLM is still very much the job of the engineer. That's actually a contract that one should remember very clearly. So I wanted to show you a real example we worked with an NGO called Bandhu, who wanted to build an application to help immigrant workers find rental housing, right? This was an NGO. They didn't have any programmers in their roles. They only had lawyers and civic activists, and they wanted to build this application. So let me show you actually how we helped them build it. So this is actually, this is an NGO. They wanted to help millions of immigrants find stable rental housing. So they wanted to build an application. Let me show you the app they built, and then I'll show you how they built it. So this is the app they built. This app runs in WhatsApp. You can sort of see how it works.
हमें बताइए किस तरह का ठहराव, कमरा सोने की जगह, पूरी संपत्ति, शहर का मासिक किराया, बजट।
मैं बंबई में कमरा ढूंढ रहा हूँ, 20,000 रुपए तक का चाहिए।
So now you can see it shows some houses. Then you can actually make a payment using UPI. You can actually sign a document for a lease and so on. So that's how this app was built, right? I mean, this is not surprising. Anybody can build an app like this, right? But what's interesting about this app was that this app was not built by programmers, right? We built a system which sort of looks like this, where the right-hand side is a natural language conversation for people in this NGO to build this app, right? So they built it by saying, oh, first, ask the user what they want, and once they found a house, charge the user 600 rupees to generate an agreement to it. But they just typed it in natural language. And this system had access to all the UPI APIs and so on, and it wrote the code, right? And the entire development was done by non-programmers. And the interesting thing I wanted to show you was that While the programmer that is doing it is not an expert, the system knows how the code looks. As a result, right, it has a lot of understanding about, for example, when you have to make a call to an API to pay 600 rupees, you have to handle various cases. Like, for example, what happens when the API credentials are wrong? What happens when the payment fails? You have to deal with all of those kinds of things, right? So the system prompts the user saying, you have to, when it fails, when there are all these error codes, what should you do? Right? The AI just engages with the user, with the programmer in this case, and helps them walk through different cases, which they found almost magical, right? I wanted to show this because, in some sense, right, when you are actually having non-programmers program, the AI also becomes a conversational agent to help you handle all the cases that you might not necessarily think about as a non-programmer, right? So it's very fascinating for me to work on this. So what I want to say is the following, right? What this taught me is that building a coding agent for programming is not just a technology problem. It's actually a human AI problem, and it's also a scale problem, because particularly if you're dealing with very large code bases, you can have code bases of the size of 30 million lines of code, 100 million lines of code. All of them cannot fit into the context window of the LLM. You have to build structures like graphs and other kinds of things that help you understand the large code bases. And the previous speaker was talking about context engineering and making sure that every task you give the LLM, you traverse this graph and find the right context that you give to the LLM. You also, as a programmer, you have many tools like compilers, build systems, and so on. It's important to expose those as tools so that the LLM can actually use them. And the final thing is actually, finally, that whether the product that you build is good, whether the correctness of it, the quality of it is something that is acceptable, that actually finally has to be owned by a human. Right? The LLM is only an assistant that helps you do that. But validation, you can actually build things like verification, static analysis tools to improve the quality. But the final judgment of what is acceptable should lay with a human being. Right, so this is all I'm going to say about code. Now I'm going to transition to spreadsheets. And spreadsheets, in my eyes, they are programs. So I want to just, they use formulas, lots of them, and really large spreadsheets are as complicated as very large pieces of code, right? So I want to show you, given that spreadsheets are programs, how are LLMs helping us in programming spreadsheets, right? The first thing I want to show you is how many of you use Excel formulas, right? Probably all of you, right? And many of you would find that actually remembering the formulas, remembering which macros to use, is probably a pretty complicated thing to do. And this is where actually coding agents can greatly help you. Let me show you one demo about using LLMs to generate formulas.
Calculated columns for last
Maybe increase the volume.
Initials, and first name. With our formula prediction auto-completion, as you type, the system intelligently predicts the formulas you need. It understands the structure of your data and seamlessly suggests the correct formulas for each column. You don't need to memorize syntax or spend time troubleshooting. Just type and let the system do the rest. Next, let's explore a lookup scenario. Here, the user wants to find the capital city for a given country, in this case, Israel. As the user types, the auto-completion predicts a VLOOKUP formula, but when they decide to use XLOOKUP instead, the system adapts effortlessly. Now, we take it a step further with a cross-sheet lookup. The user references data from a different sheet, and the auto-completion prediction handles it with ease. Here, we encounter a range of data organized in rows, what we call row major tabular data. Our formula prediction supports all types of tabular ranges, intelligently selecting the right row and the correct data range. Not all data is neatly structured. In this example, we have values representing a loan calculation. As the user types monthly payment, the auto-completion predicts the PMT formula accurately, understanding the context and providing the right solution, even in unstructured scenarios. Finally, we move to a financial statement sheet. Some ranges are missing subtotals, but the auto-completion detects exactly which ranges need to be subtotaled. When a user wants to calculate the total for both equity and liabilities, the prediction knows to sum the previously calculated subtotals. This demonstrates the system's ability to understand hierarchical relationships and provide context-aware suggestion.
Yeah, so in some sense, right, even here, the principles I mentioned to you about programs, all of them apply, right? For example, if you have a spreadsheet, a very large spreadsheet with many pages, right? And if you want the agent to help you synthesize a formula that might involve dependencies across many pages, right? You need to build an agent where you somehow use external knowledge about the spreadsheet to give the right context to the agent of which pages and which columns and which rows are even relevant, right? You can't, that's actually something you need to help the agent to do. The other thing is that you can't take what this agent is doing for granted. It might actually well make mistakes. It's your job as a user of this to check whether the numbers that you are getting make sense to you. Maybe hover around and see what formulas it is generating, ask it in explanation, and you can actually ask it questions. Why did you generate this formula? And the agent will tell you why you generated this formula, and you will have to just interact with it to make sure. Think about this as a junior colleague that you asked to create this spreadsheet for you, right? And you have to double check the answers that this system is giving, and think about it like a productivity aid, right? That's how you should think about this, right? The next demo I'm going to show you is, so far I showed you how you can use AI to generate formulas, right? But there are tasks that you can now do with AI that traditional formulas cannot do. For example, suppose you want to analyze sentiments. Suppose you have a spreadsheet which contains feedback from users. Which of those feedbacks are positive sentiment? Which of them are negative sentiment? There is no Excel formula that can calculate that for you, because that's actually a natural language problem. So what you can also do is that you can integrate the LLM into the formulas themselves, right? To get new capability. Now I'll show you this, yeah.
Here we have some coffee machine feedback, and we'd like to categorize it into one of these categories and return the sentiment and emoji representing that sentiment. We're going to make use of the new Copilot function. Equals Copilot. Classify this feedback, and then we provide it with context. So I'm going to pass in the feedback, and then I'm going to continue into one of these categories. I'm going to pass it the categories, and then I'm going to say return these columns, and I'm going to pass in the columns. Copilot is going to consider this entire query and then return the results. The results should spool to the grid. And there you have it. Category, sentiment, and an emoji representing that sentiment. And now, because this is Excel and it's connected to the calculation engine, if there's a change to any of these values, this will recalc. So I'm going to add a new category. I'm going to add maintenance. You can see that's now gone away and calculated, and I have maintenance coming through as one of the categories.
That's quite interesting, right? So now what we now showed is a new capability that formulas cannot do, but it is integrated in such a way that if you add a new category, it's just like the formulas, right? When you add a new row or a new column, the formula is just like the spreadsheet updates itself. Now it's just going to update itself, just invoking the LLM to calculate the output of every entry. So that's what these things are able to do. I'm going to show you one more one, which actually I know a lot of my friends use, which is importing data into spreadsheets, right? Like often we have a PDF file or a CSV file or something like that, and then we need to import that data into a spreadsheet. And there have been actually lots of solutions to do that. I think AI helps you do that as well. And when you import as well, right? It's not an entirely AI process. It's actually a human and AI collaborating together to make the importing successful and making sure that the final spreadsheet is the correct schema according to what you want, right? So let's just see how that happens.
An analyst copies data from a PDF and pastes it in Excel. The analyst is prompted if they want to use AI to convert the pasted data into a table. The analyst says OK, and the AI agent shows the suggested table. The analyst accepts it. The table is surprisingly good. There is only one issue. On rows 23 to 27, the data in columns E and F should be moved to column G and H. The analyst does exactly that on row 23. They are immediately prompted for whether they want AI to make the other edits. On getting a yes, the agent shows the suggested edits, which the analyst accepts. Thus, with only one copy-paste and two edits, The analyst imported the huge table on the left PDF accurately into Excel.
So what happened here, again, right, is actually another really interesting example of human-AI collaboration, where, of course, the agent and the AI don't exactly know. There's a lot of ambiguity, right? If you just take a PDF like there, and how do you import it? I mean, there's many ways in which actually you could want to create the spreadsheet that you might want to do. So what the agent does is that it shows you a possible answer, and then it watches what the user does. So when the user moves that column from here to there, the agent now takes a cue that, oh, they have moved this one particular number. And what they mean probably is not just that. We have to maybe move the entire column, right? Those are cues that the agent understands, and it redoes the importing, right? I think I predict that this is how these agents will work. They won't be able to get it first time, just like when we talk with someone and we work with a colleague. Like I sort of think about interns. I mean, I had a lot of interns in MSR, and I engage with them, right? And they might not understand what exactly you want to do. Actually, you might not understand what exactly you want to do either, because you might not even describe the task clearly to your intern, right? And it's this conversation with an agent which makes the model interactive and ultimately powerful, right? So I want to show one more, which is that so far, the three things that I showed you, one is to create formulas. The second one is actually creating formulas that use LLMs themselves. And the third one is importing. They are all specific things about using AI in the surface of the spreadsheet, right? But in the beginning of my talk, I mentioned that the way the LLMs are now proceeding is that they are becoming very agentic, which means that you don't even have to go at this level of detail to say, do this for me or do that for me. I could just think about the entire spreadsheet as an object and talk outside the spreadsheet and just have a conversational agent which says, do this for me and do that for me. And the agent knows which sheets to go and what to do. So I want to show you that.
Introducing agent mode in Excel, unlocking the full power of Excel for everyone. In Excel, start with a prompt, and Copilot gets to work while you steer and guide. Copilot explains its approach, and using its Excel expertise, applies the right formulas and charts. In just a couple of minutes, you get a full summary of key insights and validation steps to give you confidence in its work. Only Copilot speaks Excel natively. And with agent mode, Copilot builds Excel objects like table structures, formula syntax, and pivot tables. This means you can directly manipulate the grid yourself or iterate with Copilot to make adjustments. Try agent mode in Excel today and start vibe working with Copilot.
So what is happening here is the following, right? You remember I showed a similar slide for programming. This holds for spreadsheets as well, right? The invariant is the following. The problem that you're wanting to solve, be it a large piece of code or large amount of financial information in a spreadsheet, is just too large and too complicated for an LLM or an agent to comprehend, right? So the job of agent design is to make sure that for whatever task you want to solve, which is you want to do this thing to your spreadsheet or you want to do this thing to your code, the design, what people like me do, is that they actually understand the natural language instructions and use context engineering to pull the right information. Whatever portion of the code or whatever portion of the spreadsheet is relevant, you sort of make the agent focus on that information. That is context engineering. Then what you also do is that there is lots of tools and documentation. I mean, Excel has a lot of formulas. It has inbuilt functionality, right? And if you're writing code, you have compilers, you have build systems, and so on. Those are tools that programmers use. So what you try and do is that you make those tools available to the agent. Because the agent, is like another junior programmer. That's how you should think about an agent. And you make these things available to the agent. And then finally, it's absolutely important that the contract of using this is validation is done by a combination of automated review and finally human review, right? You can do certain things where you can set things up such that if your spreadsheet has to have certain properties, the certain checks, you can actually encode them as formulas and make sure that every update the agent does, it first checks whether those checks pass and only then show the spreadsheet to you. It's possible to do that. But ultimately, actually, the correctness of what these things do is actually up to the human, and you should think about the agent as a productivity tool. That's the best way to think about them. And I am towards the end of my talk. I want to conclude with this slide, which is we are entering an extremely interesting new era of agentic programming, where you don't program at a very low level. You don't write code line by line. You write code by just talking about your intent, about what you want to do. And the agent is always available, and it acts as an assistant for you to convert that intent, which is typically in natural language. You can also give examples. You can say, if I want this input, you should get that output. Those are also other ways of specifying intent. And in the spreadsheet, the context, the intent, right, could be spatial. It could be other portions, and so on. And it could be temporal as well, because you might want to first calculate one value. And depending on that value, you might want to calculate another value, right? And what is most important in designing these things is the human-AI collaboration, which is the agent doesn't always know what to do. It can make mistakes. But the art in designing these systems is in doing them in such a way that the human can inspect what the agent is doing. And if the human doesn't agree with what the agent is doing, the human can give feedback, and the agent can correct itself. The other thing that we do as tool designers is that we collect telemetry. When all these things happen, we actually figure out when the user accepts what the agent produces and when the user changes and corrects what the agent produces. And those actually, we use them as feedback, and then we either fine-tune the LLM or change the agent, so that as more and more people use these systems, right, we can learn from the data and make these agents better and better. So these are just going to keep getting better every year. That's what's going to happen, right? So the number one advice I want to give you is that if you don't use these tools, you are really missing out on them. You should be using these tools, and you should expect that these are just going to get better and better every year. That's what's going to happen, yeah. So I hope that's helpful to you. Thank you.
Well, thank you, Dr. Rajamani, for sharing your perspective on how to work with AI rather than just using it. Thank you so much. To felicitate Dr. Rajamani, I take this opportunity and welcome on the stage the Chief Credit Officer for L&T Finance. Put your hands together and welcome Usha Datta. Come on, guys, some energy.
Thank you. Thank you. Thank you so much.
Thank you so much.